Good day everyone. So today we will discuss about subset and proper subset. Let's have here subset. A set of A is a subset of B if all elements of A are in B, or all set of A is equal to B. Meaning you can copy all elements from set B into set A, or it can be some elements of set B are in A, but you cannot it cannot be a subset if some elements in A are not found in B. The notation for subset is just like longer letter C with a dash under that letter. By looking at here the example, a set A is a subset of set B because the elements 1, 2, and 3 can be found in set B. So we will just read this symbol as A is a subset of B, but B is not a subset of A. The subset should contain short or equal elements to the mother elements or the mother set. So that is why B is not equal to A because B has 5 elements while A has only 3 elements. Here, A is a subset of set C because all elements in A also elements of set C. Now let's move on to proper subset. A set A is a proper subset of set B if all elements of A are also in B, but A should not be equal to B, unlike the subset. A must be strictly smaller than B. Let's have here an example. Set A has an element of 1, 2, 3, and 5, while our set B has an element of 1, 2, 3, 5, 6. The notation for proper subset is just like longer letter C. Therefore, A is a proper subset of B. Also, A is a subset of B. But B is not a proper subset of itself because one thing is different from the two, which is proper and subset. Proper subset does not allow copying all the elements. Subset allows equality, meaning you can list down all elements from set B to set A, or from the second set to first set, while the proper subset excludes equality, or you cannot list all elements from the second set to the first set. So in proper subset, it should contain elements shorter than the main set. Another, if the two sets are equal, it will be classified E subset. While if the first set is smaller than the second set, then it could be defined, or it can be classified as proper subset and subset. If the first set has elements not in the second set, then it will not be a proper subset and not a subset. Let's try here an example. Number 1. If A If set A has an element of 5 and 8, and our set B has an element of 5, 6, 7, 8, then both can be answerable by a subset and proper subset. If we're going to rationalize all the choices given, because we're looking for the choices which is correct. If we go down to letter B, which is B is a subset of A, then it is false, because by looking at the given, B contains longer elements than A. Let's move on to letter C. A is equal to B. Here, our only choices here is subset and proper subset. We will not use equal. In letter D, A is not a subset of set B. Then it's also false, because A is a subset and proper subset. So the best option is letter A. A is a subset of B, and also A is a proper subset of B. Now, let universal set is equal to 2, 3, 5, 7, 11, 13, and 17, while our set A has 2, 4, 5, and set B has an element of 5, 7, 13, and 17. Which statement is true? As set A is a proper subset of B, by checking the elements, only 5 can be found in both set A and B, so meaning they are not proper subset. And option B, a set of B is a proper subset of universal set. If we're going to check all the elements in set B, 5, 7, 13, 17 can also be found in universal set. So we have a true statement here. While in letter C, A is equal to B. It's a false statement because it's not equal. They have not represented equal cardinality. While in letter D, A is a subset of universal set, but 4 cannot be found in universal set. So A is not a subset of universal set. If set A has an element of 2, 4, 6, 8, 10, and set B x such that x is an even number less than 10. Here we have a set builder notation, then we're going to transform this one into listing method. So set B has 2, 4, 6, 8 because by the restriction, even number less than 10 only. Now we'll be looking for a true statement. A is equal to B by counting the cardinality of the elements. The first set has 5 elements and the second set has 4 elements. So basically it's not equal to each other. Let's move on to B, which is set B, a proper subset of set A. The first qualifier there is all elements. It can be identified as a proper subset if all elements and B has the same with set A, and B should be smaller elements than set A. So B is a proper subset of A, because if we're going to check, we have 2, 4, 6, 8. Set A, we also have 2, 4, 6, 8, and 10. And letter C, set B is not a proper subset of A, then it's a false because it's already a proper subset. And letter D, A is a subset of B. It's also a false statement. The correct answer here is letter B. Let's set X has an element of A and B. Which of the following is not a subset of set X? For you to easily answer this one, we have to list down all the subset of set X. First is set X equals to A, X is equal to set B, also X is equal to set of itself, which is A and B. X is equal to empty or null set. So the answer here is letter C, which is not belong to a subset. Another, if set A has an element of A, B, C, and our set B has an element of A, B, C, meaning we have the same element, both set A and B, then they are subset to each other. And option D, it's neither, meaning not a subset and also not a proper subset, which is wrong because A has equal element of B, meaning A is a subset of B. And letter C, both, it's also wrong. For letter B, A is a proper subset of B. It's a false because set A and B has equal and the same element. For letter A is a subset of B. So this is the correct answer. A is a subset of B. If set A has a set of X such that X is a vowel in the English alphabet, which is A, E, I, O, U, and set B has a set of A, E, I, O, here we're looking for a true statement. Let's go through for letter A. A set of A is a subset of B only, which is false because A is not a subset of B. And B, letter B, a set of A is a proper subset of B only, which is also false because A is not a proper subset of B because A contains 5 elements. It should be B is a subset of A. So the answer here is letter D. It is neither of them. It's not a subset and not a proper subset. Let's have here the last example. A student's bag contains a set of A, pencil, eraser, sharpener, and ruler. And a set of B has pencil, eraser, sharpener, ruler, notebook, and book. So they only have the same element in pencil, eraser, sharpener, and ruler. So we're looking here for a true statement. Answer here is both because A is a proper subset and also a subset of B.